The objective of this tutorial is to find areas of curves under the x-axis. We will apply the note that we explained in the previous tutorial, so when the curve straddles the x-axis from both sides. You need to calculate each area alone, then you add them together. Pay attention that when the curve is below the x-axis, then you multiply the definite integration by a negative sign in order to obtain a positive answer. Look at this example. We are required to sketch the curve with the equation y equals x into x minus 1 into x plus 3 and find the area of the finite region bounded by the curve and the x-axis. We have this equation and it is a cubic function. First of all, it is good to know the expanded form for it. So let's expand. Given function y, x into x minus 1 into x plus 3. When we expand, we multiply the first two terms together. So, x squared minus x multiplied by x plus 3. Now, we will expand again by splitting the first term. X squared multiplied by x plus 3 minus x multiplied by x plus 3. By expanding, x to the power 3 plus 3x squared minus x squared minus 3x. Let's organize. X cubed plus 2x squared minus 3x. When we have a cubic function, it is important to pay attention to the coefficient of the x cubed. So coefficient of x cubed is greater than 0. Now we define the main points which will allow us to sketch properly by finding the x-axis intercept. So we set y to 0, x into x minus 1 into x plus 3 is equal to 0. Here we take the factorized form because we can easily find the roots of this equation. The first term is x equals to 0 or x minus 1 is equal to 0, so x is plus 1, or x plus 3 equals to 0, so x is minus 3. Now we go to the graph and we draw the axes, the x and the y. Okay, now we need to assign the points. The first point is when x is 0, y is 0, so here. For x plus 1, the y is 0, so here. For x minus 3, the y is 0, so here. Now we found the x-axis intercept. In order to draw the cubic functions, remember that we take the values when x is positive large values or negative large values, and we see how the y is changing. Okay, let's continue. For x going to positive large values, since the coefficient of the x cubed is positive, then the y moves along with it, so into positive large values. Also, for x going to negative large values, then y goes to negative large values. When x goes to negative, y goes to negative. So it will start from here and pass through minus 3, goes up and then goes down to the 0, and then it goes through the 1. And it continues for large positive values of x and y. So this is how it will look like. In this way, we use the x-axis intercept and we use the property of how the y changes along with the x. Now we finished the first part. In the upcoming tutorial, we will find the area of the finite region bounded by the curve and the x-axis.